Okay, so let's talk a little bit about the course. Right. Welcome to our first class today. Right. This is on time series analysis. Right. Basically, let me brief you a little bit some basic info on our course as well as the instructor, which is myself. Okay, so I'm Prof. Eng, so you can call me Dr. Eng, Prof. Eng, so no issue. Right, this will be my consultation hour. So every Tuesday and Thursday lah. So you probably can meet me during this time in my office, my room in H1160. Right, this is my email. You can always drop me an email, or also you probably, if you want fast, you can drop me a message in the MS Team. I will on my MS Team, so I will try to reply you as soon as possible. Okay, so feel free to drop me a line in using email or your MS Team lah. Okay. All right, so let's talk about the course itself, right? What is the expectation? I guess from this junction, you probably arrive at this stage whereby for FE students, banking finance student, right? On top of these three programs, we are also expecting risk management students coming in to join us. Okay, so basically, these are some sort of the general path route that you will go through, which is relates to statistics lah. Okay, because this is time series is a quantitative subject, so basically the basic foundation must be there. Okay, so you see that in your year one, all right, you have take subject like the QD2, right? Things that's still relevant today, which is on our course, is that the way you perform hypothesis testing, right? This kind of skill you still need it, okay? On using t-statistic, z-statistic, for example, right? And the regression analysis is the one that you need, okay? So basically, from time to time, we might want to revisit back the stuff that you have learned in your year one. Okay, and of course, year two, year three, you take a subject on econometrics and basic econometrics that deals more with the regression analysis. Okay, so we are still using it, the skill that you learn here, right? But our focus, right, our primary focus will be on the type of data that we are using. Okay, so previously in your basic econometrics, you deal more with cross-sectional data, am I right? And then in your econometrics, you still talk about cross-sectional data, and on top of it, you touch a little bit on the panel data itself, right? Not so much on the time series, right? Except some topic like simultaneous equation, the ARDL model. Okay, so these are the things that you learned previously. All right, so today we are going to look at the subject itself on time series analysis. So what makes this subject very different is that the data that we use. Okay, so later on when we talk about topic one, we will see the uniqueness of time series data. Why there is a need for us to spend 14 weeks to talk about the how to analyze the time series data. There are very special things about this time series data, right? Offer us a lot of opportunity, and of course, when you know if there's opportunity, of course, there's also some challenges lah. Or we don't say problem, we say challenges. So normally we don't talk to your to people say, oh, we have problem. No, we face some challenges, not problem. Okay, so this is what we are going to look at on the subject itself, time series analysis, deal with time series data. Okay, and of course, I don't see there are risk management students taking this semesters. So previously, yes, maybe soon, Okay, so let's talk about the cost, right? So basically what you need to expect is that, of course, we deal lots with the special characteristics of the time series data itself, right? And of course, we pay attention to two key focus. Number one, the cost basically deal much with forecasting. Okay, so how do you forecast the future value based on the previous value? Okay, the first half of the semester, we talk more about forecasting, how do you forecast and so on and so forth. All right, so that is the first half. The second half will be like learning how are you going to understand the real world by looking at the relationship. Okay, so in practice, probably we'd like to know question, or we're interested to find out whether a typical set of variable, is there any relationship between a set of variable or not, because we would like to understand how the variable y, if you remember, y is the dependent variable that we normally talk about, how y behave, can we use x to understand the behavior of y, is this a policy tools that can help us to boost the y, and so on and so forth. So in this case, two parts. First is on forecasting. Second is trying to examine the relationship between the two. So all these, the topic that we cover, right, basically deal with these two themes. First is on the forecasting. Second is to examine relationship, right? So of course, by the course itself, right, the software that we're going to use is the eViews. Okay, right. So why we are still focusing eViews? Of course, we throughout the course, we probably would like to emphasize on the use of Excel as well, because from the industry, you see that industry the industry is still using Excel. Right. Of course, we have people start to talk about Python itself. Probably next semester I will start with that one. But for this semester, we will look at Excel and eViews, right? So the reason why we still use eViews is pretty simple. You see that, for example, Bank Negara, they are still using eViews. For example, if you join JP Morgan, the investment firm, the basic condition or the basic requirement for you to join them is you have to know eViews. Right, so especially those who deal with time series data, eViews still relevant today. Okay, because of the easy interface, it's very convenient, right? So probably for this course, we still are looking at the eViews. Okay, so that is the things. Okay, so let's look at the learning outcome, right? So why we want to know about the learning outcome? Very simple, because all our assessment, right, regardless it's midterm assignment or presentation or project and whatsoever, all those assessments, they are designed to test your ability to achieve this learning outcome. Okay, so when you are given an assessment, for example, you are sitting for a midterm, right? What to expect? So from the course learning outcome, you can identify what are the skill or the focus that you have to pay attention. Okay, so let's look at CLO1. CLO1 is very simple, apply econometrics models by using time series data. So the emphasis is what? How do you use econometrics model, right? So we will put this as the focus for assessment 1, which is your midterm. Okay, right. Secondly is to display the ability to produce time series report. Okay, so again, another essential skill required by the industry is the ability for you to produce and report, right? So I guess some of you already go through your internship, right? You see, you recall back how do you write your report? So when we talk about report, there are some certain skills. So therefore, for this course, the second things that we will try to do is to look at the ability to produce a report now, because writing report is a way to communicate, right? So no matter how good you are in doing data analysis, if you do not know how to communicate, also pointless, because you can perform bombastic analysis, but how do you communicate this result or findings to your audience, especially those audience that know nothing about statistics? Okay, so it is a skill. So therefore, we will examine this in your CLO2. Okay, so CLO3, very simple. How do you use the software to help you? Because nowadays, of course, in your elementary paper, like for example, QT or basic econometrics, we are still emphasizing on whether student can perform the test or not, how to calculate the test, how do you examine the test. Those are basic skill, right? But now we know that in practice, we don't really like look at the T table, look at the Z table, and so on and so forth, because all this can be done easily using software. So again, your ability to pick up useful information from the software output is another skill that we look for in your assessment 3 or CLO3, right? And of course, lastly is your CLO4, which is the overall expectation on this course, what to expect in this case, right? And of course, normally we examine you through the final exam. So these are the 4 essentials CLO4 that we expect student can achieve after attending 14 weeks class. All right, and as mentioned, right, how all this can be examined is by looking at the assessment. So the way we design assessment is focusing on how we can examine whether student can achieve this CLO1 to CLO4 or not. Okay, now firstly is the midterm test, right? We will tentatively schedule in week 6 during the lectures hour. So probably I will see you in week 6. So during lecture class, right? And the test consists of 1 question, cover topic 1 and 2. Okay. Right. Secondly is the project, right? So project is a group work. So we expect that there are 4 team member maximum. Okay, you can have less than that, right? But the maximum is 4 person. If you are keen in doing solo, no issue. I'm welcome that. So you can do alone, no issue. Okay, right. That is the project, which is the written report lah. Okay, next will be your problem sets, right? So there will be some data analysis problem sets for you, right? And then you have to present the result or your findings. So this laboratory work is on individual basis. So we will schedule the presentation accordingly, right? So, and of course, it's your final exam. So as usual, session A and session B. Session A is compulsory. Session B, 3 select 2. So pretty standard, right? So all total up together is 100%, because the weightage you see, look at the midterm is only 10%. Okay, so the report and the presentation will be 2020 and so on and so forth. Okay, so that is basically the things. Right, so one thing for you to take note is that for BBF student, I'm so sorry, risk management student, you have to fulfill this compulsory passing requirement, right? Whereby you have to ensure that your continuous assessment score at least 40. Final exam, you also need to at least score 40. So this is very pretty risky business, right? So if you score here 100, but your final exam you score 39, also no use, because the requirement here is that there are 3 requirements. Course continuous assessment 40, final exam 40, right? Overall together must be 50 otherwise you will get F. So these are the things that for BBF student you need to take note. Okay, so how are we going to go about on this subject? Is pretty simple. We will do some special arrangement, because my intention is that I want to balance between theory and practical. Okay, so therefore, for lecture class, right, we basically go through the 2 hours lecture class. Okay, so week 1 to week 3, right, we will do full online, right? No hybrid, because I don't think hybrid is working, right, because of the equipment. So we do just full online lah for our lecture class. Okay, so I will see you physically in week 4. Huh? So we will have face-to-face class in week 4 after you come back from Chinese New Year celebration. Okay, so for tutorial, we will have workshop type of tutorial. It's not the normal tutorial that we see, because for this tutorial, I basically want you to have some hands-on experience with the data. How do you analyze the data by addressing certain issues? Okay, so in this case, we will have about for 14 weeks, right? There are 7, but 1 is for presentation. So I will prepare 6 workshop for you, right? So tentatively, this is the schedule, right? So in your timetable, you should able to see it, right? You put it in week 3, week 4, week 5, 6, 8, 10, 11, 13. Okay, but because of week 3, we have difficulty to meet, so I will rearrange this to week 4 onwards. So week 4 onwards, we will meet for this so-called the tutorial class. So for each workshop, it will be about 3 hours. So 3-hour workshop, so we can discuss the theory and the hands-on together. Okay, so that is the things that we're going to do after we come back from our Chinese New Year break. Right, of course, I have my consultation hour. Feel free to drop by. Okay, so no need to do any booking. So if you, let's say you see me in my room, you are welcome to just drop by, no issue. Or you can reach me through email or MS Team. Okay, so that is the how we can go about this course. Okay, so let's look at the topic, how many topic, and basically what are the content will be covered, right? Okay, you see, basically, as I mentioned, right, for this course, 2 key focus. Firstly, on how do you do forecasting, right? So that is the first ultimate usefulness of time series data, right? So the first 4 topic basically cover how the time series data behave. So we will go through topic 1 on the basic concept for you to grasp the terminologies, right, or the jargon that we use throughout these 14 weeks, right? We have to know a little bit about the background first before we comprehend the detail. Okay, so that is the things, right? Topic 2 is talking about the 1 key assumptions about the time series data, right? Unlike cross-sectional data or panel data, is one very unique special requirement for you to fulfill when you want to use time series data is the assumptions of time stationarities or uniroot, right? So for those who look at research method, or you start your FYP already, if you're using time series data, you will always encounter these words on uniroot or stationarity. So basically that referring to one of the key assumptions that we see. Okay, right, and topic 3, once you know the characteristics or the requirement for using time series data, we will look at these 2 topics that emphasize more on what? How do you forecast a series? So occasionally want to know, oh, what, let's say I want to forecast sales for next month, or forecast inflation next month. I want to know CGPA and so on and so forth. So how do you do a forecasting? It's not a purely guess. So how do we systematically conduct forecasting, right? And of course, topic 4, we deal a lot on modeling the volatilities of a data. This is particularly interesting because if you are finance student, if you are economic students, right, to us, right, volatility or fluctuation of the series signal us some signal. Okay, so volatility basically imply risk, right, for financial analysis, right? A very volatile data indicate there is risk there. For economists, volatile series means what? It is there is a lots of uncertainty there. So these are the things that we try to quantify and we try to measure. Not only it's like previously you learn how do you measure this kind of risk. Very simple. You just look at the standard deviation and you look at the variance, right? So that is just what we call a point estimate. So we are no longer using that, but we want to moderate. So throughout the years, right, along the way, so how the risk change. Also, we will learn some model to tackle how do you measure risk. Okay, right, that is the first half, right? The second half of the course, we will talk about examine relationship, right, between variables. Okay, so how important for you to know this is that if you know there is a relationship between the two, of course, if your intention is to understand the characteristics of series or you want to do forecasting, this kind of existence of relationship does help us to understand the real world. Okay, so that is the second half on examine relationship between a set of variable. Of course, we always start with simple relationship by we're looking at two variable and then we expand it to multiple variable. Okay, so that is basically what you expect. So two key focus. Hopefully you get something out from this course if you are decided to take this subject. Okay, so that is some overview of the subject. Right. Ken, any question on this?
No questions.
Oh, yo, thank you. Okay, so it's very simple So basically, this is what you can expect for the course. Okay, so if no issue, then let's start our topic 1. Okay, some basic concept in time series analysis. Let's talk about this. All right. So basically for this topic, right, these are 5 key issues, right? So normally when I start a topic, I will let you know what are the key focus. Okay, so this is to ease you to do your revision, right? So like for example, topic 1, what is the key focus? Okay, so if you know the key focus means what, later when you want to do your revision, you basically know, these are the major things that we have to understand or the key element that you need to know. Okay, so this will help you in terms of preparing for your revision, because when I want to set my question, for example, midterm question or final exam question, so this will be the key focus that I will focus when I design my question for exam or midterm so basically, I don't want later on you do your revision in a very scattered way here and there where you don't see the key focus. So that is the things. Okay, so for topic 1, because this is basic concept, right? It's a very general topic, so therefore we have more key focus compared to others. So later on when we see topic 2 onwards, right? I try to narrow down the key focus to 3 key focus, 1, 2, 3. But for topic 1, because it's a very general topic, so we will look at 5 key focus. Okay, now firstly is that before we talk more about the technical part, right? So in topic 1, we need to know our ingredient, right? Our data. Okay, so we will talk about the data itself. Right, what are the how do we deal with time series data? What's so special about this time series data? Why do we need to spend 14 weeks on learning how to analyze time series data? So the first key focus that we are going to discuss is about the uniqueness of the data. So how do we deal with it? Okay, right. Secondly is we're going to look at a very general view on what are the commonly used models, okay, to analyze our time series data. Okay, so here, if you look at this, right, if you recall previously, we talked about this model, right? What is this model? So what do you understand by the words model? We're trying to investigate an issue, right? We call ourselves as an empirical guy, right? You want to find evidence, so to help you to learn about the real world. Okay, so we always start with a model. So what is this model? Right, model is just a very simple statement, right? Model is a way for us to see the real world. So everyone will have your own model. So if I give you an assignment or you do your FYP, right? One topic. So if I have 10 group, then I will have 10 model. Everyone should have your own model. Okay, so your model can be different from my model. It is pretty normal because model is our way to see the real world. Everyone have different way to see the real world. But the key question here is that, or the major issue is that we need to convince our model is more preferable than others people's model to describe the real world. Okay, so we look at the model. How do we see the real world? Okay, by looking at using this time series data. Okay, so thirdly is to look at the characteristics of the data itself. We call it a stochastic process. Okay, so this is one of the very crucial assumption when we use time series data. So we assume that the data, right, or the stochastic process of the data, stochastic process is one of the key assumption, right? We look at this key assumption later on. So these are the basic things that we need to know, okay? Because when we talk about time series data, two key assumptions. First is this stationary process, which is one of the key assumptions of this stochastic process. The other one is the second half of our class when we talk about relationship, right? So this is normally what we call the most popular question in exam, whether we talk about midterm or final, right? If not coming out for final, then it coming out for midterm, because this is the one key crucial thing that you need to know about using time series data, right? This is the crucial assumption. Okay, right. Then we talk about the trend pattern in time series data. So you will see this trend pattern, right, in time series data only. You can't see this in cross-sectional. So this is somehow is very unique to time series data. So we look at the trend, why do we have this trend? How do we model this trend series? All right, and of course we talk about the problem. What are the problem when using time series data? Because they are so special. The data, they are so special, but therefore when you use it for regression purpose, it will give you a lots of problem or challenges. So one of it is what we call a spurious regression problem. Okay, so that is for the scope that we will cover for topic 1 on the time series data itself. Okay. All right. So look at the first one. We want to examine the data first. So how do you define time series data, right? How time series data they are different from others, right? Pretty simple. The observations of time series variable, all right, is made at the date t denoted by this. So this is the notation that we use, right? Okay, so let's look at this time series data. Okay, so time series data. So remember what this is the ingredient, right? So what's so unique about this? Okay, so if you still recall, right, in your QD2, you talk about the different type of data. How many type of data that you have? You remember? You have cross-sectional data, you have time series data, you have panel data. Okay, so what is the function of this data, right? Data is the ingredient. Okay, so you want to pick up information, right, in the data. So they are very informative from two angles. One is your n dimension, one is your t dimension. Okay, so you see that for times cross-sectional data, it involves what? If you involve many individual, so you use the notation I, but only one period of time lah. T is equal to 1. Okay, for example, midterm test result for this student, for example, for this semesters. So one period of time, but many cross-sectional individuals. So individual can be what? Individual can be student, individual can be household, individual can be countries, and so on and so forth, depending on your scope, right? So this is what we call cross-sectional data. For time series data, very simple. You only look at one individual. Okay, so probably it's one countries, but for many years. Okay, so for panel, it's basically combine both many individual involved many time period. So a group of individual, how they behave over time. So in this case, we look at this. Okay, so you will see that what data for you to be used in analysis, it always depends on your objective, right? We cannot say, oh, panel is the best. We cannot say, oh, time series less powerful compared to the panel. No, right? So it's always about suitability. It's not about the best. Okay, so it's just like you're choosing girlfriend or boyfriend, right? You're not choosing the best. You're choosing the one that's suitable for you. Am I right? So it always depends on your objective, what you intended to do. You look at the information content of these 3 different type of data. Okay, now let's say, for example, so I interested to see what? I interested to see, let's say, I want to examine how firms respond to interest rate announcement, for example. Okay, once central bank announced there is a drop of interest rate, right? So how firms will behave. So if my objective is to investigate how everyone behave at that particular moment, so you see cross-sectional data will be more relevant. Okay, so that is the things. Now, if my objective is to study, for example, how firms, right, behave over the years, how a country develop. I want to look at economic growth for countries, how they develop over the years. So in this case, time series data will be more useful. Okay, but if I wanted to see how the firm in that certain industry behave over a particular period of time, then panel data will be more relevant. So in this case, you have to always examine the suitabilities of the type of data that you want, right? So same thing like when you want to decide for your FYP, you think about, hey, what topic you're going to do, you have to think about the data. Can you get the data? Is it the cross-section data? Is it time series data? Or is it a panel? Right? What will be the key focus? Okay, so that is the things. Oh, so time series data will be useful when you are interested to look at how individual behave over the years, or over a certain period. Okay, so that is the things. Okay. All right, so we learned about the notation, right? notation. So let's say we have variable y. Okay, we know that, okay, you have variable y. So you will see that what? You have to differentiate between concept of population versus sample, right? So from the beginning until infinity, this will be your population. For time series data, huh? 0 to infinity means what? If you are looking at GDP of countries, who is your population? Day 1 until in future, right? It's never ending for countries. So what do you see is that you only get a sample here. This is your sample. This is what you observe. Okay, so the term that we use is what? Observation. What do you see? Right, in other words, this is your data point, sample data. Okay, so how do you do the notation? Is pretty simple. If it's a cross-sectional data, I stand for what? I stand for individual. Right, time series very simple. T. Time stand for time. Right, panel. IT. So from here you know, this is information content. So if I put a sub I means what? Individual, the value is different. So many individual. T, every year or every period, the value is different. So the information content will be on T dimension. Right. Sub IT means what? Both dimension, they are changing. Okay. So this is how you talk about the notation. Right. And one characteristics of time series data is that each observation, we have a fixed time interval. Okay. So we normally do like this, T equal to 0. 0 means now, now. Right? Future value plus 1, plus 2, plus 3, plus 4. Future value. Historical value, -1, -2, -3. Right? This is what we call lag value. This is what we call future value or forward value. This is what we call lag value, previous value, historical value. Right? This is the notation that we use. So how do we define time series data is that we observe the data point at the fixed time interval, right? Every period we have a point, right? They are in fixed form. So that is the things that we see. Okay, so the interval is between right T plus 1. The T can be anything, right? The T can be referring to the frequency of the data. So remember, what is frequency of the data? Frequency of data. How many frequency? So frequency of data referring to what? How many time? Number of time we observe for one period of time, for 1 year. So 1 year, how many data point you see? Okay, so if 1 year, 1 time, we call this annual data. Okay, so like for example, 1 year, 12 time, monthly data. So 1 year, weekly data, how many time? How many years? How many weeks we see in 1 year? 50, 52 or 55, 54, right? 52, right? Okay, so that is the frequency. We normally use the notation M, M1, M12, M42. So frequency of the data. How many data point you see in 1 year time? Okay, so this is what we call low frequency. This is why if you go here is high frequency data. Okay, we can have daily data, even higher. Okay, or we can have real-time data. Okay, so which means what? In minutes, in second. Okay, so this is what we call intraday data. Okay, so this is the terminology that we use. This is for you to understand when most of the time the students look at the exam question, they will tell you, actually I don't know what the question want. What is the root of the problem? Very simple, you do not know the jargon or the terminology. So in topic 1, we spend time on talking about the terminology so that you can understand. Okay, so next one, let's look at the basic operator, right? How do you analyze the time series data, right? So we normally kickstart with what? How do you transform your data set first? Okay, so the first terminology here is the lead and the lag, right? Lead, as mentioned, right? Lead means future, you are in front of me, lead. Lag means you are behind of me. Okay, so T minus is lag, plus is lead or forward. Okay, so these are the notation that we use. All right, now another time series operator that we normally use in practice is what we call first differences. So first difference. Okay, so the notation here is the triangle. We can also have second difference. Right, you can have third difference, fourth, fifth, five, so differencing. So here, the first difference very simple. What does it mean? Let's say we have variable y. First difference here means what? This period minus previous period. This is what we call first differencing. Okay, right. So second differencing. Second differencing means first difference this year minus first difference last period. Okay, so this is a very commonly used data transformation in doing time series analysis. Why this is so popular is simply because it tells us about what changes. It tells about changes. Okay, right. Under what situation we want to know about the changes? So this is particularly useful when we look at the growth. Want to look at the growth rate. Want to look at the movement. Okay, so how data change. Want to look at the changes. Okay, so this operator that is useful when we want to model this kind of behavior, right? For example, growth rate. What do you want to know? For example, I want to know economic growth. Okay, I want to know inflation. Inflation is what? Change in the price level, am I right? I want to know the return in stock, in investing in stock market, for example. Okay, so all these variable require you to do this first differencing of your data, right? So how? Example. So if let's say, for example, in my FYP, I want to study economic growth. How do you measure economic growth? Right. So economic growth in loosely term, this is basically referring to what change in the income of the country, right? So how do you measure this? Right. So in your basic economic subject, you use real GDP, right? But this is income, it is not growth. So how to measure growth? So we know it is change in the income. Okay, so how do you measure change in the income? So economic growth equivalent to what? Your GDP, real GDP. Real GDP this year minus real GDP last year divided by what? Real GDP this year or last year? This year or last year?
Last year.
So last year, T or T minus 1. Then we times 100% because we want the unit measurement into percentage form, right? Okay, so first thing you have to think about this year or last year, am I right? So you compare what? This is changes, right? Changes. You want to compare the changes with this year or last year. So normally girl, you know lah. You want to compare what? Compare your current boyfriend with your previous ex-boyfriend, right? So you always put last year. Okay, so this is what I call a simple growth rate. Okay, then you calculate a number here. It tells you how much the economic growth. Okay, so this is the basic understanding of generating growth rate. For example, inflation. Same concept. I'm going to use what? CPI this year minus CPI last year divided by CPI last year times 100%. Then we get the percentage here. Right? So, but right, as an empirical guide, okay, this is what you study, right? Concept-wise, it should be calculated in this way. But when you analyze your data, we seldom really do this. Okay, so instead, right, in time series analysis, we want to measure growth rate, right? We use first differencing in the log series. Okay, so what does it mean? So I basically will use what? Log ln, natural ln y minus natural ln yx times 100%. So if I'm looking at economic growth, I'm going to log my GDP, real GDP this year, minus log GDP, real GDP last year, times 100%. You see that the growth rate that I calculate, this number will be very, very close to the growth rate that I see here. These two numbers, very, very close. Okay, so this is normally how we do things. So same thing later on when we look at stock market data, right? We normally use first differencing. This is what I call first differencing. First differencing is what? This value, this period minus last period. Okay, a simple way is for you to transform your data. The first thing before you start any analysis is to transform or to clean your data first. And this is normally how you do your data transformation. Okay, so that is the things. Right, but we know that this is behind the scene. When we analyze data set, this is the operator that we use. Okay, so for Bank Negara, you be surprised they're still using this very old-fashioned. Okay. Okay, so that is first differencing. Okay, so another operator that we use is log, for example, to change them in log form. So when using first differencing, we also use this log, right? So in basic econometrics, you have learned, right? What are the reasons we log our data? So these are the examples that we discussed just now. Okay, so that is some of the basic data transformation, right? Next is to look at the uniqueness of the data. We're still looking at the data, right? Okay, now why do we use time series data, right? So under what situation we want to use time series data, right? There are four situations, right? How unique is time series data? So in practice, these are some of the reasons why we focusing on time series analysis, okay, because of the uniqueness of the time series data. Okay, now, simple, why do you use it? Simple, because you want to answer quantitative questions. So quantitative means objective. You want to answer a question objectively, okay? For which the cross-sectional data and panel data, they are not able to do so. Okay, so what's so special is about this time series data? So first is that the time series data allow us to develop forecasting model, right? Okay, so what is this forecasting model? Unlike other type of data, let's say you, for example, we have cross-sectional data versus time series data. So you will see that if we have variable y, right? So you will see that this is time dimension, right? So what's so special about time series data is that if you're given a y series, okay, so right, one uniqueness of time series data is that the data point, remember what is the name we call this data point? We call this observation, right? So observation 1, observation 2, observation 3, observation 4, right? They will be in time sequence, meaning to say what? The sequence does matter. We must have year 1 first, year 2 come later, year 3 come later on, right? We cannot change, right? Okay, I put year 2 first, but year 1, year 5, year 3. So the sequence tell you certain information. Okay, not only the value. The value tell you a piece of information. The sequence also tell you another piece of information. They are rich in 2 dimensions. So this time dimension. Okay, so in this case, one of the most conventional use of time series data is that time series data normally will show a very common pattern, which is what I call a trend pattern or trending pattern. It can be a linear trend, it can be a non-linear trend. And then you're looking at the movement of the series in the past. You have this tendency to like, oh, this, what will be the next? T plus 1, which is 6. What will be the next? Can be go up, can be same, or can be go down. So the key usefulness of time series data is that they give you the previous trend, right? And then based on the previous trend, we can forecast the future trend. Okay, because as I mentioned, right, the value and the sequence signal you certain information that allow you to do so, right? But you look at cross-sectional data, right? Let's say this is GDP. Okay, so what do you have? I have 200 countries for this year, or for last year, let's say, for example. So what do I have? So country 1, country 2, country 3, country 4. So you don't see any pattern that allow you to do the forecasting. It's very difficult for you to do the forecasting. Okay, so therefore, the key uniqueness of this time series data is that it allows us to develop forecasting model. Why? Simple, because of the data itself, right? They come in time sequence manner, right? So we cannot simply arrange the movement, right? Not like this. I can put Malaysia first, then put Singapore later. So the way I arrange my data, who comes first doesn't matter, right? Because it's cross-section data, but time series cannot. Okay, but because of this time sequence manner, Okay, so the observation in time sequence manner. So therefore, it allows us to do some forecasting by developing a forecasting model. So this is the first key uniqueness of time series data to help us to do forecasting. Okay, so this is why you see how when you the time series data analysis start to become popular is because of this. People use time series data for forecasting pattern. Okay, so why we want to forecast? Very simple, because we want to set our goal. So we want to do our budget, right? Annual budget, for example, government every year also want to do budget, right? Because they want to plan for the planning ahead, So help to anticipate changes within the market. So for company, they also want to do forecasting, right? Because every year you see that World Bank or IMF, they produce a GDP forecast, or Ministry of Finance also will do the forecast because they want to do planning for the anticipation, right? So that is the things. Okay, right. So that is the first one. Secondly, why do we want to, or how useful is this time series data? Is that the time series data allow us to measure or to study volatilities. Okay, so what is this volatilities? Again, volatility. Okay, so volatility here means fluctuation, fluctuation, or changes. Okay. Okay, so you will see, when we talk about time series data, when you compare low frequency data versus high frequency data, okay, or you compare long-term versus short-term data. For example, interest rate, you have a short-term interest rate, you have long-term interest rate, right? This kind of data, right, they behave differently. Okay, so for example, economists normally deal with low frequency data. Example, we look at the labor market, right? Salary, wages seldom change much, right? So it's steadily increase lah. Okay, wages. Right? We look at the stock market. Okay, you see stock market. Very volatile. Daily data. It's annual data, for example. So the fluctuation is quite steady, not much changes. But for daily data or real-time data, the fluctuation is huge. Okay, so for this fluctuation, we call this as volatility, as mentioned, right? Compare this case and this case. So this is what we call very noisy lah. Data is very noisy. Okay, market is very noisy. So that is the things. This one is very calm, right? Not much changes. Okay, so you see, when the time series data, they behave differently. You need different tool to model to capture this kind of movement. So for high frequency data, you see this kind of volatility happening, right? So for us, volatility imply what? Risk for finance. Every risky business like this fluctuation, right? For economists, Volatility imply uncertainty. Okay, so no matter you are coming from finance background or econ background, you are interested to capture this kind of volatility in the series, like interest rate. So long-term interest rate normally is quite stable, right? Short-term interest rate probably like 3-month interest rate, 6-month interest rate, for example, like more volatile. So of course, this volatility offer us a way to study risk or uncertainty, right? It tells us more than what it's supposed to do. It allows us to do forecasting. It allows us to measure risk, for example. So you can't see this in cross-sectional data, right? So look at some example. Okay, so this is typically what you see for our GDP per capita, measured in USD. So we look at our GDP per capita means what? Income per person. So in terms of USD, you'll be surprised. This is in $1,000. So last year, on average, we earned about $11,000. Can you believe it? Oh, we are so rich, right? So this is why we always say we are reaching a high income nation soon, right? It's just that by right, in year 2020, by right, we are there already. But because of COVID, we are not there yet. Am I right? Do you feel that we are very wealthy? Do you feel that we are belonging to high income country nation? Okay, but the data tell us otherwise, right? You see that on average, everyone, you and me, right? We are earning about $11,000, not ringgit, dollar. Okay, but you see that the income increasing steadily. Not much fluctuation except this financial period, the crisis period. So we have 3 rounds of slump. So this is on the Asian financial crisis. This will be on global crisis, and then you see the COVID. Okay, all right. You look at the higher frequency data on monthly return, for example. Particularly when look at this example, look at the top growth, right? You see that during the COVID period, so you see more fluctuation. These are the things that we're interested to measure. Later on, we have 1 or 2 workshops to look at how do we measure these kind of things. Okay, right. So it's useful for forecasting. It's useful for us to capture the uncertainty or risk, right? And of course, we talk about the second theme of our course is to look at to study the existence of long-run relationship between a sets of time series data. Okay, so because time dimension does matter in this case, right? So what kind of extra piece of information that we can grab, right? Unlike cross-sectional data, we can't really examine this, but for the time series data, yes, we can distinguish between long run and short run. Okay, so the difference between long run and short run, how long is long and how short is short? Why does it matter? Right, as first thing, right, the key difference between these 2 long run and short run, right? Why should we care about whether it is a long run or it is a short run? Okay, it does matter. Okay, now you see, in practice, right, one of the things that normally we have this kind of thought in our mind, or there is a saying about what, okay, right? For example, a student will tell me that, miss, what we learn actually is useless lah. We learn so many theory, all cannot be used one. We try to memorize theory, exams come out a lot of theory, but in practice, we don't see that the theory is working. right? And especially finance, how many theory you have? Economics, how many theory you have? You have the growth model, you have this and that. Finance student, you have a purchasing power parity, interest rate parity. There are so many theory that you learn. Okay, now bear in mind that, so all those theory that we learn, they are a long run concept. So theory works in the long run. Okay, so why it make this so interesting is that in practice we always say, yeah, this one useless lah, right? It is not helping at all because we don't see this work in the real world. Okay, so what is the misunderstanding here? It's very simple, because we're not able to differentiate between long run and short run. Okay, all the theory that we learn is a long run concept. By right, it should be work in the long run. But how long is long? Okay, so most of the time you don't see that the theory is working in practice is because the real world, not long run yet, we are still here. So in practice, right, what we have, company is so too young, market is very young, not yet long run. So the theory that we learn not able to apply in the real world because still short run. So one of the key usefulness of using time series data is that we can model long run and short run together. So this one will be our goal, our long-term path. So this one is now, our action now. So time series data allow us to differentiate between long run and short run. So you want to see, hey, is the theory still hold? You need the long run concept. Should we do more? This is a short run concept. So one key advantages of time series data is that they allow us to study these two phenomena, short run and long run, right? We will do this in the second half of our course. How do you measure the long run relationship and the short run relationship? So that is the things. So there's another uniqueness of unique offering that the time series data will give us to study the existence of long run relationship. Okay, so like this case, you look at this, right? This is the movement of the price or consumer price index. This is the broad money. Broad money is the amount of money that central bank print. Okay, normally you see that, government always says, crisis time, very lots of firms suffering. So how do you save the nation? Very simple, you print more money. Can we do so? Okay, so that is the question, right? Printing money, you see amount of money available in the market steadily go up. Okay, and then you see the price also going up. So is there any long run relationship between these two? If there is a long run relationship, what does it mean? Print more money, then you give more inflation. Is this the one that you want to see? You don't want to see, right? So is there any long run relationship between these two? So that will be an empirical question that we can examine by looking at the long run relationship between assets or variable. So there is another usefulness. Okay, lastly is to estimate the dynamic causal effect. So dynamic is this dynamic. Dynamic, So dynamic long run effect. So the dynamic, what does it mean by dynamic? So you in your econometric, you learn dynamic model, right? So what do you understand by this term dynamic? Are you dynamic? Don't dare to say. Is Yuta dynamic? Okay, so dynamic here means changes. Okay, so do you change over time? Right, is Yuta changing every year, every day? Yes, right. So we say that, oh, Yuta is dynamic, you are dynamic. Okay, so dynamic here means changes, right? changes is what? You remember how do you measure changes now compared to previous year, right? Okay, so how you behave now compared to previously, right? Okay, so changes. So changes is a short-term concept, short-run concept. Okay, so beside, right, helping you to decide whether there is a long-run relationship or not. So another usefulness of time series data is that it allows us to study the dynamic of the short run or the short run movement or changes in the data. Okay, so causal means what? You wanted to see, okay, let's say, for example, X and Y. I want to see whether this cause Y or not. So causal in time series, there is a special causal relationship that we want to pay attention to. So we call this a Granger cause. Okay, so you have to be very, very careful, right? The Granger causality test that you learn in your econometrics is different from the common understanding about X cos Y or Y cos X, right? So let's say what I say, X cos Y. X cos Y is different from X Granger cos Y, different meaning, Okay, so if I say X cos Y means what? X must happen first, then Y will receive the impact. From X. So this is the action. Then impact on this one. This is what we call X cos Y. Right now, but we can't really examine this causal effects in econometrics. So we can only examine Granger cause. So when I say X Granger cos Y, meaning to say what? X contain information to predict Y. It's different story. There is no action in X. There's no impact on Y. It only tells you that X is a very informative variable for you to predict the future value of Y. Like that only. Okay, so in the short run, when we talk about dynamic causal, means that we are looking at this. Does X contain information to help us to predict Y or not? Okay, so this is another uniqueness of time series data that you can use to study it. Okay. Okay. Also, we want to see that in the short, we see there's a long run trend there. It seems like they are having relationship, but in the short run, do you see that printing money will cause inflation in the short run? So you can change this kind of question into an empirical question. So when I say empirical question means what? You can verify it. Okay, so what we're trying to do in using time series data is that we want to verify or we want to examine what we suspect. So I want to ask, you see, this is why when you do your research method or you're doing your FYP, you always start with a question. Does printing money will bring inflation? Right. So this kind of question, you want to find answer, right? So the answer that you wanted to do or you want to find is the one that you set as an objective. I want to investigate the long-run relationship between broad money and the CPI, for example. Okay, so how do you do that? You want to use empirical analysis. Empirical means what? Empirical means it must be evidence-based. Where the evidence coming from? The evidence coming from the data. Okay, so that is basically what we do. Okay, so and we see that time series data offer us for special usefulness for us to tackle our research question in practice. Okay, so that is basically the first half of our first key focus of our cost, right, which is on the data itself. Okay, so the second one is the commonly used time series model. Okay, so let's look at it. Okay, so in this case, let's look at the commonly used time series model. Okay, so what is this? Okay, so first thing first, model. So we are empirical guy. Empirical means what? We see the real world in a very objective manner. Okay, we want to verify, we want to test, we want to examine. Okay, so how do we see the real world? We use a model to view the real world. Okay, so what is real world? Okay, this back to your basic statistic QT2, huh? One big, one small. What's this? So this is what we call population, right? Population. Okay, so this is population. Population is what? All, you remember your QT2, you always try to memorize the item, the keyword like all item, all subject that you're interested to study. Okay, so this is what we call, right? In statistics, we call this a population, right? In our human language, we call this a real world. Okay, so you want to see, you want to study everyone. You want to look at the behaviors. You want to look at stock market behavior, for example. You want to look at investor behavior, for example. So that they will be your population, right? But unfortunately, can you see the real world? You can't. The real world is too big for you to see. So what do? You do statistic. What is statistic? You observe sample and learn about the real world. You observe them and then you learn about them, about the real world. You're hoping that sample behave like population, right? This is your understanding, right? You look at the statistical jargon. We observe. What do? We do descriptive statistic. We want to learn about the real world. We do infer. We infer, right? Infer means learn about. Making inferential statistics. Okay, so here what do? You do sampling. Okay, so same thing. I want to see the real world. Is there any long-run relationship between two variables? I cannot see the real world because from now to future, I cannot observe them. What I can observe is just a small sample period. So I'm looking at this sample period and then I'll try to infer what will happen in the futures. Okay, so therefore you see, you observe, you study sample to learn about the real world. So how do you see the real world? So you have to have your model, your model on whom? Your model on population. You suspect, you believe or you suspect the real world work like this. Okay, so how do you set your model? Simple. I believe that Y can be determined by a set of variables. So this is my model. On the right-hand side, this is what I believe. This is what I suspect. I will put it here, X1, X2, X3, X4. So time series model, I want to know over time how series Y behave. Okay, so I start with a model, time series model. All right, on the right-hand side, who will be on my right-hand side? Things that I suspect. So I put 1, 2, 3. Maybe you put A, B, C, right? Your friend put D, E, F. It doesn't really matter because this is our view. This is what we believe. This is what we suspect. Is it true? We don't know. So we need to verify it. We like to examine it. We want to show or want to prove, or we want to convince others this, yes, it plays a significant role. So in this case, when we want to build a time series model, very simple. Okay, what kind of time series model that we can use to learn about the real world? And normally in doing time series data, we learn about the real world by looking at these two. Number one, we want to forecast. Why? No? Number two, we want to understand or want to explain why. This is normally what we do in practice. Okay, and we want to see what on my right hand side, what we believe, is it true or not? How I understand or how I see the real world, is it true or not? This is what you do. Okay, so what kind of time series model commonly used? So you need to build a model. What type of model can be used? Right, then you put it in. Okay, so looking at this, these are the commonly used model. Number one, this is the classical one. You want to build a time series model. So how do you build it? The first one is what I call a smoothing procedure. Second one is what I call decomposition method. Right now, this is a very old tool, a very classical analysis on time series data. Right, it doesn't involve very complicated pattern. Okay, because this is procedure, this is method, no modeling yet. Right, it's just a way for us to handle our data. Right, smoothing procedure or decompose and also decomposition method. These two are very classical tools in time series data, mainly for forecasting purpose. It doesn't help us to understand how Y behave, but it helps us to forecast Y instead. So these are a very classical forecasting tool. All right. So although we say it is a very classical tool, right? You will be surprised, right? These classical tools make a comeback now because of big data, because of machine learning, right? Because of data science. These very old-fashioned things make a big comeback. So therefore, we also try to cover for this subject because even though it is a very classical tool for us, for econometrician, for statistician, these are nothing new. But because of the new opportunity in the big data, right, it make a big comeback. So we will spend some time in talking about how do you do smoothing, how do you do decomposition. So we cover this in topic 1. Right. Now, the second one will be regression model. So regression is our core skill or core analysis. Right. So regression from year 1 until now, you're still talking about regression. You see that they are very simple, but they are very useful. Okay. So from the classical, you see that this can be further refined into a regression model. Okay. So a little bit advanced from this classical way. Okay, then we have this what we call univariate model. Univariate model, very simple. You look at the name. So univariate, variate means variable. Uni means one variable, right? Univariate model involve only one variable. Who? You, yourself and your mistake. What does it mean? So yourself means your historical value. mistake, right? So this is what we call a univariate model, where your y, it depends on what? Your past historical value lah. As well as your mistake. Mistake is things that you don't know. So residual like 1 until residual like 2, residual like Q, for example. Oh, so your historical value help you to predict the future value. Okay, so this is what we call univariate model. Past historical value, informative to forecast future value. Okay, so what is on your right hand side? Only your own historical value or your own residual. So that's what we call univariate. Bivariate means what? Bivariate, same lah. You can look at the name, you can infer already. Bivariate. Bi means two variable. So you believe what? Y can be explained by X. So this is two variable model. Okay, multivariate. Simple lor. Multi means many lah. Variable. So you can have y is a function of x1, x2, xk, for example, multivariate. Or there are many, these are commonly used model in doing time series data. So we cover all these models in our course. Okay, so these are the things. So for topic 1, we will cover this the classical way. Okay, so let me cover the first one. So then off we go. So first one is smoothing time series data, right? So noise and signal. So grab these two concepts. Noise and signal, right? Noise means chaos, chaos or volatilities or fluctuation, right? Signal means what? Signal means the direction. Okay, so you're looking at the data. Let's say you have a sales data like this. It's a daily sales, right? So what can you see from here is that for any time series data, we're trying to identify these two components in a very rough manner. Okay, so we want to see how noisy is the data and what is the direction where it goes. We call it a signal. Okay, so most for forecasting purpose, these are the two core components that you try to identify. Okay, so most credible forecasting method notice how individual value varies and whether they tend to drift generally up and down. Okay, now this drift, right? Drift means what? Drift means the signal. Varies means what? Varies means differences. Differences means what? Chaos. Chaos means what? Noise. Okay, now from here, you would like to identify the noise and the signal. Okay, signal means the drift. Drift means whether you see upward trend or downward trend, generally going up or going down. Okay, so that is drift. Drift. So we will concentrate with the direction. Varies, which is the fluctuation. Okay, changes, chaos, noise. Okay, so from here, first you try to identify the signal, up or down. It can be like this, it can be like this, it can be like this, it can be like this. You don't know, right? So this is why the smoothing method trying to clarify the situation. Now, looking at the graph itself in a very casual manner, first you look at the signal. In most of the time, you see the signal is not strong. Okay, it seems like non-linear, it seems like going up, it seems like going down. Signal here means what? Signal means you're going to detect, or you want to say something about the direction of the series itself, going up or going down. Okay, this is normally what your boss will be asking. The sales how up or down? Like this one. We look at the graph. Can you say anything about this? How to answer your boss? Up or down? Can you say, oh no, first up, then go down, like that, or seems like go down, or seems like go up, or on average go up, on average go down. See, this kind of information is very confusing. So therefore, smoothing method or smoothing procedure basically help us to clear all the confusion by trying to trace a clear signal from your data. Okay, right, removing the noise. How do you do that? By smoothing the series. So as mentioned, each forecasting method account for two components. So one is the signal, one is the noise. Signal, remember, is the drift. Drift is what? Is the direction. Go up or go down. You always think about your potential boss. Hey, sales how? Up or down? Or stock market today how? Up or down? So you want to know the signal. Okay, so how do you see the signal? Signal is not strong because there is a noise there. The noise is the one that disturbs you. So you have to remove this noise or you have to smooth the noise. So how do you do that? Simple, by using moving average. Okay, so average the value, okay, and try to see whether there is a upward movement series or downward movement series. Okay, so you're looking at this, right? Take the average, you don't see anything. Long run average like this means what? Every day you total up, you just get okay, you only can tell your boss, okay, average sales for this period is 1,000. Sometime up, sometime down. Most of the time up lah, but average is this. So it's not so informative. So therefore, another way for us to do that is to smooth out the noise. Right, smooth out noise means what? This one, the edges here, you try to smooth down the edges by reducing the noise. So average cannot do the job. You have to do the moving average. Okay, so moving average is a simple and common way for you to smooth the series. Right, so let's say, look at this. Right, again, you have this series, right? So this is the sales values, let's say, for example. Right, just now we see that by just taking all the average is not helping. You just get a smooth 1,000 average. It doesn't tell much about sales, the trend, the direction of the sales, right? So what do you do? By averaging observation 1 to 3, let's say 3 days moving average. So what do I do? 855 plus 847 plus 1,000 divide by how many? 3. Then I get the second observation. 847, 1,000, 615 divide by 3. So moving the average. So what moving average I use? I use this is what I call MA3 lah. So 3 period. So I will see, and I plot the moving average. You see this line, it become more smooth, not like this short, right? So of course I can use MA4, MA5, MA6, right? The more, the bigger the number you go, the more smooth your curve will look like. Okay, so once this curve smooth, right, what will happen? It will basically remove the noise lah. When you do moving average, you are doing what? You are reducing the noise. This one, reducing the noise, so that you can see clear signal. Okay, so you see your peak of the sales is around this period. Okay. All right, so that is basically what we call a smoothing method. So the next one, time series decomposition, we will cover this, I guess, next week. Okay, so can let us conclude here. Right, so today we just cover some two major agenda. One is on the cost review, cost overview. Hope that you can have some expectation with you to decide, to help you to decide whether you want to register for this subject or not for this semesters, or you want to consider other alternative. Right, then we kickstart with topic one by looking at the special or the uniqueness of time series data, what time series data can offer us. So 4 things, right? It can help us to do forecasting. It can help us to measure risk or volatility. It can help us to estimate long run effect. It can help us to estimate the short run effects, right? So these are the key focus one. The key focus two will be on how do we model. So we kickstart with the most classical one, which is the smoothing method or smoothing procedure that trying to help us to trace the signal in the data. Okay, so that is basically the thing that we cover for our first week class. Okay, any question? Can follow? Week one, topic one. Can huh? Still can yeah, can sure can, not still can, sure can. People. Oh. Yeah, so ticket, yes, good. Okay, so or any things about the course you want to ask before we go off? Then don't forget to scan your QR code. So every week, from time to time, you check your QR record you know the system sometimes not stable. You thought you scan already, but somehow you didn't scan it. Just for this kind of matter, you just MS Team me, let me know. I will do for you. Okay, so if no more question, then I guess we can conclude already. So thank you so much for attending the class today. Hopefully I can see you next week. Week 1, week 2 add drop period. So kindly do your registration. So tutorial week 1, week 3 until week 3 no class. Week 4 only we have tutorial. Lectures still on, but all online. Okay, so thank you for coming. Let's conclude here, and I'll see you next week.